Okay, now that we know how to find rational and irrational zeros, now let's talk about how to find your complex roots. Just as a polynomial function can have real zeros, rational and irrational, it can also have complex zeros. Find all the zeros of the polynomial function. Below, simplify all irrational and complex solutions. So here we go. Let's go back through the process. If you have x to the fourth minus 4x squared, this is a quadratic form. We're going to factor it like it was quadratic. Two sets of parentheses, x squared times x squared, adds, multiplies would be a -6 and a +2. We're going to set it equal to 0 in order to find those roots. This will not factor again, neither one, so let's set each equal to 0 and simply solve. Move the 6 over. Gives you x squared equals 6, so therefore x would equal plus and minus the square root of 6. There's two irrational roots. Move the 2 over, gives you x squared equals -2. Now you cannot take the square root of a negative and obtain a real solution, so therefore this must be complex. We do have to split it. X equals plus and minus the square root of -1 times the square root of 2, which would be x equals, try that again, x equals plus and minus I root 2. So this one has two irrational and two complex. Okay, number 2. The exact same thing. We're going to have to use slip and slide on this. So that would be x to the fourth plus 31x squared minus 32. Two sets of parentheses, x squared and x squared. Adds, multiplies would be a negative or a positive 32 and a -1. Set it equal to 0 so we can find these roots. Neither one of that, well, actually this will factor again, so we now have x squared plus 32 times x plus 1 times x minus 1. That is difference of squares. Difference of squares factors into conjugates. Set now each factor equal to 0 gives you x squared plus 32 is equal to 0. Here you have either x is -1 or x is +1. You can go ahead and find those two answers. Move the 32 over, gives you x squared is -32. So therefore x is equal to plus or minus the square root of -32. That's going to be plus or minus, let's split it, the square root of -1 times the square root of 32. And I'm going to go ahead and simplify the square root of 32 into that. And that's going to be x is equal to plus or minus 4I root 2. So there's your two complex solutions. Number 3. X to the fourth minus 16. Now, a lot of people think that, hey, we can just move that 16 over and take the fourth root of it and we're done. However, we're going to miss some of our roots if we do that. We're looking for 4 roots here. So let's factor that. Two sets of parentheses. That'd be x squared and x squared. Because this is difference of squares. Difference of squares factors into conjugates. X squared times itself and 4 times itself. Now here again, we stopped a while ago and we factor that again. However, if you would like to, you could, now that it's quadratic, you could stop and actually just set each equal to 0 and solve it instead of factoring it again. Here, move the 4 over, gives you -4. So x will equal plus or minus the square root of -4, which you would have to split. X equals plus or minus root -1 times root 4. So that would be plus or minus 2I. Over here, move the 4 over, gives you x squared equals +4. So x is equal plus and minus root 4, which is plus and minus 2. So therefore, you can factor that again into difference of squares if you'd like, or you can just go ahead and set it equal to 0 and solve. The next one, let's say set it equal to 0. Let's start trying to factor. Let's factor out a -2. And you are left with x to the third plus 8. This is sum of cubes, so we're going to have to use our sum of cubes formula. So I've written your formula down here. Now let's write that in the right form. You have x to the third plus 8, so we can write that as x to the third plus 2 to the third. So we simply have to, everywhere we have an a, put an x, everywhere we have a b, put a 2. So now our formula turns, or excuse me, our equation turns into a plus b, which would now be x plus 2 times x squared minus x times 2 plus 2 squared, which would be 4. So there is your factored form. We're now going to set each factor equal to 0. This one, when you set it equal to 0, really doesn't do anything. Negative 2 can't be 0. When you set x plus 2 equal to 0, you get x is negative 2. Now, setting x squared minus 2x plus 4 equal to 0. With that, it will not factor, so therefore we're going to have to either use completing the square or quadratic formula. And since we have an even number here and a leading coefficient of 1, we'll go ahead and use completing the square to do this. I think it'll be pretty easy. Here's your steps again, x squared minus 2x. Step number 1, move your 4 to the other side. Step number 2, we're going to complete our square. The way we complete our square, we take half of this and multiply it times itself. That gives me a positive 1. We add that to both sides. Factor. That should be a perfect square now. That'll be x minus 1 squared is equal to negative 3. To get rid of a square, we're going to square root, so that'll be x minus 1 equals plus and minus the square root of negative 3. Move the 1 over, that'll be x equals 1 plus and minus. Square root of negative 3, we're going to split into the square root of negative 1 times the square root of 3. So that would be, as the next answer, x equals 1 plus and minus I root 3. So there's your 2 or 3 solutions. You have 1 real and you have 2 complex. Number 5. 2 different groups here. We can try to factor by grouping. Got this set equal to 0. First group, we're going to factor out an x squared. You're left with an x minus 2. Second group, you're factoring out a 1. If there's nothing there to factor out, when you're factoring by grouping, make sure you factor a 1 out of it. Both groups, you have an x minus 2 that we're going to factor out, and you're left with an x squared plus 1. Set each factor equal to 0, gives you x equals 2. And then when you set x squared plus 1 equal to 0, you do have to solve it. Move the 1 over, you get x squared equals negative 1, so therefore x would equal plus and minus the square root of negative 1, which we know is I. So there's your 3 solutions. Again, looking for 3 solutions here as well. Factor by grouping. First group, we're going to pull out an x squared. Again, I don't stress it enough. You're setting this whole thing equal to 0 because when you set y equal to 0, that's how you find your x-intercepts. So that's right why we set equal to 0. So factor out the x squared, you're left with 3x minus 4. Factor out a positive 12, and you are left with 3x minus 4. So factoring by grouping did work here. Factor the 3x minus 4 out of the 2 groups. You're left with an x squared and a positive 12. Set each factor equal to 0 since this does not factor again. So you're going to do 3x minus 4 is equal to 0, or x squared plus 12 is equal to 0. Here you get x is 4/3. There's one x-intercept. Here, move the 12 over. It gives you x squared is negative 12. So therefore, x is equal to plus and minus root negative 12. Now let's break that down. That'd be positive negative. We can split that into root negative 1 times root 4 times root 3. So that would be a plus and minus 2I root 3. Okay, number 7, also factor by grouping. Set it equal to 0 so that we can find our x-intercepts is what we're looking for. Let's see, factor by grouping. Let's factor out an x to the 4th. You're left with 2x minus 5. Let's factor out a negative 1, and you are left with 2x minus 5. So factoring by grouping did work. Factor out a 2x minus 5, and you're left with x to the 4th minus 1, which we're going to have to try to break down again. Do not set that equal to 0 until you get to quadratic. That's when you can set it equal to 0. So now you have 2x minus 5 times This is difference of squares. Difference of squares factors into conjugates. That'll be x to the fourth is x squared times itself. 1 is 1 times itself. And now that you are now at quadratic, you can set each factor equal to 0. You could, if you would like to, factor this again. That's also a difference of squares. You can do it either way. So you have each factor equals 0. 2x minus 5 equals 0. Move the 5 over, divide by 2, you get 5 halves. First answer. X squared plus 1 equals 0. Move the 1 over, gives you x squared is negative 1. So x would equal plus and minus the square root of negative 1, which is I. There's your two more roots. This one, move the 1 over, x squared is equal to positive 1. So therefore, x would equal plus and minus the square root of 1, which is 1. So there was a total of 5 answers, and you see 1 real, 2 complex, and 2 more real. So therefore, 3 reals and 2 complexes. Another factor by grouping, set it equal to 0. We're looking for x-intercepts. Factor out an x to the third out of your first group. You're left with an x and a 7. Factor a negative 1 out of your next group. You're left with an x and a 7. Factor out x plus 7 out of both groups. You're left with an x to the third and a minus 1. This is difference of cubes. So let's write our formula down. And now let's identify our a and b. We're factoring x to the third minus 1, and 1 is 1 to the third power. So everywhere we have an a, let's put an x. Everywhere we have a b, let's put a 1. So bring down x plus 7. A minus b would be x minus 1. A squared would be x squared. A times b would be 1 times x. And b squared would be 1 times 1, which is 1. So now that we are down to quadratic, set each factor equal to 0. When you set x plus 7 equal to 0, you get negative 7. X minus 1 equal to 0, you get x is 1. When you set x squared plus x plus 1 equal to 0, then you're going to have to use a different method. It's quadratic, so let's use our quadratic formula. So there you go. And again, I like to, there's your a, your b, and your c, or actually all three 1. I like to do b squared minus 4ac first. So let's come over and do our discriminant. B squared minus 4ac, b to the second power, that's 1 to the second power, would be 1 minus 4 times a times c. A and c are both 1, so that'd be 4 times 1 times 1, which is 4. So the stuff under your radical is negative 3. So we said we will have complex answers, and that is under the radical in our formula, so you can go ahead and clean it up and split it into the square root of negative 1 times the square root of 3, which would be I root 3. So therefore, my other two solutions, I can probably just come up here and write them. Negative b would be negative 1 plus and minus the stuff under the radical we cleaned up into I root 3 over 2 times a is 2. You can leave it like this, or you can split it. It looks more like a complex answer when you do split it. So let's do negative 1 over 2 plus and minus. If you would like to, you could do the root 3 over 2 and put the I next to it. So there you see the real part and you see the complex part. So it looks more like a complex number when you do split it into two separate things there. Okay, in the next part, we're using the rational zero theorem. And again, remember that the rational zero theorem says that all your possible rational roots are all the factors of 20 over all the factors of 2. So the first thing let's do is let's list all those possible factors. So there you go. There's all your factors of 20. Here's all your factors of 2. Every combination of the factors of 20 over factors of 2 I've listed there. We then experiment. We try to find something that works. And what I mean by working is we've got to find something that is a factor of this function. We've got to find a 0 out of this list. We're going to use synthetic substitution to try to figure out which one's going to work. And this problem would have actually taken a while because looking ahead, the one that's actually going to work is a positive 5 halves. And that's not going to be one of the first ones that you pick. So let's go ahead and just remind you how to do this. Let's use 5 halves to break this down. You have 2, negative 5, 8, 20, negative 20. Synthetic substitution, we're looking for if I were to plug in 5 halves, f of 5 halves, would I get 0? So bring down the 2, multiply by 5 halves. So 2 times 5 halves, the 2's cancel, leaves you with a 5. Negative 5 and 5 is 0, 0, 8. Now 5 halves times 8, cross cancel gives you a 4 and a 1. That's going to be 20. And you do see that it works. So therefore, let's rewrite our function. Our new function is f of x is equal to, since 5 halves work, we can now say x minus 5 halves, and this, 2x squared plus 8. Again, that's constant x squared. Now, we really are glad we don't have to do that again because since it was x to the third, it broke it down into we now have quadratic. So we can now set our function equal to 0. So we have x minus 5 halves equal to 0 so that we can find these zeros. 2x squared plus 8 is equal to 0. So move the 5 halves over, gives you x is 5 halves, which you already knew was one of our zeros here. Move the 8 and the 2 over, gives me x squared equals negative 4. So therefore, x is equal to plus and minus the square root of negative 4. You're going to split that into the square root of negative 1 times the square root of 4. And that's going to be plus and minus 2i. So there you have 2 complex solutions and 1 real solution. Number 10. First thing, let's list. And again, anytime you see 4 terms, you like to try is factoring by grouping going to work because that's going to be so much faster. Here, it's not going to work because you'll have an x minus 2 and an x plus 3 when you factor that out. So that's not going to work. So let's make our list of possible rational roots. And numbers like 48 is always scary because there are several here, but luckily this was a 1, so therefore you had all those factors over plus and minus 1, which just left you with these as possible rational roots. Now let's try to find something that works. And here you see I've used, I divided by x plus 2, and it did come out to be a factor, or excuse me, a remainder of 0. So f of negative 2 is 0, so that's going to be a root or a 0. So now let's break our function down. Our new function is I divided by x plus 2, and I got x squared minus 4x plus 24. We can now set it equal to 0 now that we're down to quadratic. Set each function equal to 0. X plus 2 is 0, and x squared minus 4x plus 24 is 0. So that gives me that x is either negative 2 or this quadratic is not factorable. You can use your quadratic formula, or since you do have an even number here, we can complete the square on this. Let's just complete the square. That'd be x squared minus 4x. Move the 24 over. To complete the square, half it, square it. That's going to add 4 to both sides. Factor it. That's going to be x minus 2 squared equals negative 20. So it's going to be x minus 2 equals plus and minus root negative 20. X minus 2 equals plus and minus the square root of 4, square root of 5, square root of negative 1 will be 2i root 5. Move the 2 over and you're finished. X is equal to 2 plus and minus 2i root 5. And there's your other 2 solutions.